Alright, we'll probably consider this just theory, one of the theory videos. I'm not sure where I'm at on numbers on that, but a non-mathematical theory, because there's really not much math needed, or at least not in the greatest sense. We're going to talk about the magic eye. I do. So, and well, no one knows how it works. It's magic. So that's it for the video. Thanks, guys. No, seriously. We're going to talk how it works and some of the different supply voltages to it and what's going on. These are actually relatively simple. I've got one here that had a bad filament, open filament in it, or heater, I should say, actually, be correct, because it does have a indirectly heated cathode, and they do. They're generally a 6-pin base. The big pins here, which is kind of hard to tell that they're bigger, but they are your heaters, and then the rest of the pins connect to the various component inside. Now, the typical, there are various different ways of drawing it, a couple different ways anyway, but the typical schematic diagram is like this. And you have, of course, your heater, and you have a cathode, you have a grid, because there's basically a triode on this side. So you have a triode tube here, so cathode, grid, the plate of the triode, that's what the T's for. And then on this side you have what they call the target anode, and that's what TA stands for. But from the plate of the triode's plate, it has a, shown as a grid, and I'll show you what it really looks like, but a control for this target. Now, to hook them up, generally the cathode will go to ground. Real simple. The grid goes to your AVC circuit. And there's various different points that can be hooked into that AVC, but it hooks into the AVC circuit, so that as the AVC fluctuates, then the eye tube will change. And anybody's ever seen them, they go from either completely closed to up to about 90-degree opening. And otherwise it's green in color, and when they're completely closed the entire area is green, and then when they're opening up that area is duller, not green, and they just open up. Well, that's done by the grid. That's what it's sensing, the AVC voltage, and it works that out for you. Now, the target anode, this comes up and goes to your B plus. Okay. This one, the triode plate, goes to a resistor and hooks to the target. Well, also hooking to B plus. Depending on the actual voltage of B plus, this will either be a 500K or a 1 meg resistor. One of the two. And generally when you've got a problem that the eye tube don't seem to be working as good, or is not as bright, or having some troubles, it's usually the culprit of that resistor is floated out tolerance. It's went up in value. They're generally located in, and I didn't bring the radio out here, but in the socket that plugs onto the eye tube. They're usually located right there, and so that's where you have to go to change it out. But that's usually your culprit right there. That's basically the connections that are made. Now, how it works? Well, it's actually fairly simple. First, let's talk about this grid. Now, if you notice, I made a slight little difference in this tube. They generally have a cap, top cap on there, because down inside there's your cathode right in here, and right in the middle of that is the heater. So that light can be blinding. You know, it's glowing, and you don't want to see that. So they put a top cap on just to shadow that out, so you don't see it. So I just cut, for clarity's sake, I cut the cap off. So, and that's its only purpose. It's just in there so you don't see the filament or the heater. Now, and I'm hoping I can show this pretty good. This right here, this little piece of metal right there, is that. Okay, that connects down through right there, which is connected to here, and this is the plate of the triode. Now, coming up through the center is cathode, and this here, this area right here, this is what turns green. This is your target. Okay, and what happens is you fire up the tube, you know, you turn the power on. Of course, the heater heats up, the cathode heats up. This is hooked to B+. It's got to find the lead connections, which are right here. Going down, one of these goes down through the tube, and this is pretty kind of hard to see it. It's going down right through here. Anyway, it goes down the pins. But anyway, this has got full B+ on it. Once the cathode gets to proper temperature, it starts emitting electrons, and they'll start shooting across. When the electrons hits the surface here, it has a phosphorus on it, material, phosphorescent, and all that means is when the electrons hit it, it produces what they call photons, or light. And in this case it's green. Most of them are green, so it turns green. Now, if this here, this little piece here, this little control grid for the target, if this grid, which is hooked to the plate, so in other words, if these two are at same potential, same voltage, exactly, then the eye is closed. But if they're not, if this plate starts having current going through it and the voltage drops on it because of the resistor, when you get current going through a resistor, you get a voltage drop. When you get that voltage drop, this voltage drops here on this plate, so it's not the same as the target anymore, which in turn lowers the voltage here on this part, which appears now less positive in respect to the target, or more likely, or more accurately, it's kind of like a negative voltage. And a real deep tube theory explains how that works, but basically what that does is it starts blocking some of the electrons coming through here, because this is less positive and appears more negative with respect to the plate here, and you'll start blocking the electrons hitting the target, but only in this area right here. So as this starts blocking electrons, it starts appearing to be more negative to this plate right here, then it starts, the electrons coming from here bend away, and as they do, they start creating a shadow. None of them are hitting in a spot here, so you don't get any of that green phosphorus color. Now, when it hits its maximum peak, maximum difference, and there's ratings on how much negative voltage that's got to be, but when it hits its maximum, it'll be approximately 90-degree angle that shows up on there. So anywhere under that max from 0 to a certain point. Now this is 6U5. It generally runs at, well, its maximum plate voltages, B plus, is 250. They range between 200 and 250, but at around 250, then then the negative voltage on the grid will range from 0 to minus 22 volts. Now, how does that work on the grid? Well, I have discussed a little bit about how a grid works and what it does in previous videos, but basically, when the grid is just neutral, 0 volts on it, negative or positive, don't matter, it's just 0 volts, then the maximum amount of electrons that can come off the cathode makes it to the plate. As this becomes more negative, less and less electrons flow to that plate. There is a point called cutoff that this grid gets to, a certain negative voltage, it literally stops all the electrons. Now, when the grid is at cutoff, when you hit that maximum, say for a 6U5 running around 250 volts, would be minus 22 volts. So if AVC hit minus 22 volts, a real strong signal, then it shuts off all the electrons going to this plate, which in turn means no current's going through this resistor, which means now the potential is the same. If I don't have a voltage drop here, then technically these two then are at the same voltage, which in case then you get the full green clear around. But if it's, say, at 0 volts, then I got the maximum current going through, which I have the maximum voltage drop across the resistor, which means I got the maximum difference in plate voltages, which then makes this most appear to be the most negative, which blocks the most number of electrons to that target in this area, so you get a 90-degree deflection. To kind of give you a visual of looking at that, one great little tool that uses these is a lot of capacitor testers and bridge testers like the ICO and 950B. So we're going to hook a capacitor up to it, and I'm going to shut off a light here, and I'll probably have to lower you down just a little bit. So have fun on the ride, and let's see if we can. Oh yeah, we got it pretty good. We'll kind of zoom in a little bit. Alright, there's a 6E5 I-tube, I believe it is. It might be a 6E5. I'll talk a little bit about the differences. There, right there, we have cutoff. We have the maximum voltage going to the grid, the control grid on the triode. There, we're at our maximum opening, approximately 90 degrees. There's our maximum difference between the two plate voltage. Basically, grid would be pretty well 0 volts. So, and then anything in between will make different angles, so as you float through that. And to kind of give you some idea, in a lot of your tube manuals, the one I'm particularly going to show you is the, I believe it's RCA's RC13, or it might be 14, I can't remember which number, but in those they have, I'll back up a little bit and hopefully this will stay in focus. I noticed on the last video that there is flickering in the screen as it refreshes, and it's not the same as the camera, so the camera has a hard time keeping focus. So I'll try to keep my hand up here, maybe it'll focus on it, maybe with a little pointer. But they'll have a grid or a graph like this showing the different voltages. They'll tell you that if it's got 250 volts B plus, your resistor, that series resistor we talked about, will be a 1 meg. They show you the current, both of the plate and the target, But the main thing is they show you the shadow angle as it goes up from 0 volts. You get a full 90-degree deflection coming down to the maximum voltage at cutoff of a little over minus 20. It's about minus 22. 0 angle. So that's what they show you. Now if you're running a lot lower voltage, you can run these down to about 100 volts. In that case you want the resistor to be a 500K, and that will run at 0 volts, about a 90-degree deflection down to here, which is about -8 volts. That is cut off. So I wanted to kind of show you, and they show you basically how they did it and everything. Here's another way of drawing the eye tube. So so anyway, I hope that's was of interest to you. I mean, there's not much to these. They're basically just a triode tube. Kind of blank out here, come back down. So, and turn my light back on. But that's, you know, that's all there is to them. There's not a whole lot. They come in different shapes and sizes. Oh, the difference between the 6E5 and the 6U5. The 6E5 is a little bit more sensitive on its cutoff and grid voltages, so it reacts a little bit differently, a little quicker actually, than what the 6U5 or 6G5 does. So, and they also can be instead of these cylindrical tubes like this, they come in the shoulder style tube. You've seen those. It looks like kind of like the Coke bottle. So anyway, that's really what I've got on these. I hope that kind of helps you understand them a little bit and stuff and how they work. They're pretty easy to hook up and pretty easy to operate and stuff. So, but if you do have a tube that doesn't seem to be wanting to work very good, check that resistor. And like I say, it's usually in the socket or right at the socket. And the older style where they had the cup like socket that fit on, in other words, this style like this, it's actually literally down in the back end here. It's down in there. You actually have to solder them with them in place. So, and unsolder them. There's some newer ones where they had just a socket, wasn't molded up like that, and then it's a little easier to get the resistor. But check that resistor, and that's usually your culprit, especially if the tube tests good and everything. And in your tube tester, a lot of them will go ahead and test the triode, make sure it's operating right, and then they'll do a test of closed and open. So anyway, I guess thanks for watching, and hopefully I didn't say too many times. And almost said it. So I'm not sure where we're at on the next video, but it'll be coming up. I'm not sure what it'll be. So until next time, thanks for watching, and I'll see you on the next video.